Welcome back, TIA Part PE. Now we're looking at loading and access considerations. So loading and access to your building or proposed site is often something that you need to consider in a TIA to make sure that you can actually get on and off the site, you can get your garbage collected, that the access points are going to be safe and suitable for people to use. And yeah, this is usually, once again, part of the requirements that you need to fulfill to get zoning proposals, because at the end of the day, if the building gets built and the garbage truck can't get into your garbage collection area, that's going to be a problem for the local council or whoever it is that is collecting the garbage again, and the council will want to have assurances that you have thought about all of this in your proposal. So quite often the zoning bylaws will include actual specific requirements as to what you need. So here we are once again looking at Toronto because I happen to be familiar with this area. So they have type G loading areas, which are for garbage trucks, and then they have A's, which are for really big trucks, B's, which are for small trucks, and so on and so forth. And then also, more practically, you might actually need to go out there and assess, not just rely on the zoning bylaws, but actually assess how much loading there is available on the site, or if you're in a neighborhood or something like that, are there loading spaces available on the street? Will it be reasonable for your proposed site, to be using that? This is all sort of part of the process and something to think about. So here we go. This is a fairly simple site again, which looks where they're required to have a certain number of sites, one type G, one type C, and two type Bs in the zoning bylaw for some sharing. So the two type Bs for what is presumably the office use and the retail use is allowed to share the type G or the type C or whatever the specifics are. And that makes a lot of sense because, of course, these loading spaces are going to need to be on the ground floor, and they will take up a lot of space, and then they'll also take up a lot of space to actually get you in and out of them as well. So here's an example from, again, a site in Toronto that I think I worked on, where you're actually trying to get the garbage truck in and out of this site. So it can actually be quite complicated because, of course, the garbage truck is going to need to turn around on your site as well, which is going to take up a lot of space, because the last thing that the local council would want is the garbage truck to go in and then reverse out, because garbage trucks reversing is inherently not going to be very safe. So you therefore want the garbage truck to be moving forward when it comes out of your site, not reversing across the street. Again, here's another example on the same site. So we're looking at how the single unit truck, it's called. So that's going to be a truck that's a bit more for deliveries and those sorts of things, is going to get in. Looks like they are actually sharing the same space, but as they are different sized trucks, it's been an option of having to do a turning movement analysis using one of the popular programs is AutoTrack. You can do some of this stuff with some turning templates. So just printed out templates for each of these things, and baking paper essentially. You just trace in where the truck's going to go. But of course, AutoTrack is a much more precise engineering-y computer program that allows you to do it natively within CAD. Even then, the most telling way of doing this is to get your hands on one of these garbage trucks and go out and see what it can do. If you really want to test whether the garbage truck's going to fit into your site, go into an empty parking lot, get out the cones, and map out what the site's going to look like, and then see whether the garbage truck can actually get in and out safely. There'll of course be some, requirements that you must have, a certain amount of space between the garbage truck and the wall, so there is some room for driver error or drivers not being precise. and sometimes that's actually included within the turning templates. And then you can see here we've got overall length, forks up, fork down. All of these details do occasionally matter. Anyway, moving on, car park access, of course, is again going to be an issue. How are you going to get cars in and out of your site safely and with sufficient sight distance and all of these sorts of things? So again, all the fundamentals of intersection design would sort of come to the fore here, although it's not going to be a high-speed intersection environment. It is still going to be that sort of bit between the intersection and the car park design. You can see here in this particular site, they've actually included a curved entryway to get down into a ramp which goes down into the car park, and having that first turn in the car park being a gentle curve makes a lot of sense. So further on down in the car park, we're looking at more sharper turns, because we can assume that someone driving their car is going to cross over the line and get around here. But here we are coming down the very first ramp, which is probably going to be quite steep and not a huge amount of sight distance. So you'd sort of hope that you're going to keep people going as a sort of a transition from the idea of you were out on the street and now you're coming down into this car park environment where you might have to be a little bit more cautious in your car. Going around corners because things are a bit more constrained. So, but having a really sharp turn at the top of the ramp is probably not going to work out too well. And then, of course, you've got other things to think about inside access as well. So there looks to be a whole load of lockers here, but more importantly, the bicycle storage. So this looks to be the whole area for where you're going to park your bicycles, which might have helped to reduce the vehicle parking requirement for the site. And so one question is, how are people going to get there? Are they wheeling their bicycles through the lobby and then going down to the bicycle storage area in the lifts? Or are they going to ride their bikes down the ramp? How is this going to work? These are all things that you would need to think about as a traffic engineer on this site, in conjunction with the architect. So there's going to be a lot of back and forth between your design team and the architect's design team. And a lot of these sorts of things are actually going to be driven by the larger scale building issues. So particularly the loading areas, all of this space here, is going to have to be free of any columns. So somehow or other above us, this entire building is going to have to be held up by some sort of column system, but you need all of this space here to accommodate the garbage truck. So all of this area here is going to need to be free of columns. So you've got quite a big span here from there to there, and from here to here, all of which is somehow going to have to work structurally. And that has implications for the cost of the building. So maybe you might going to need a large structural beam here that's going to help hold the building up. And of course, this is going to be an iterative process where columns might initially have been in one particular place and then have to be somewhere else. And of course, when you get down here into the car park, these columns here are actually holding up the entire building, because the parking garage has to have columns running through it. And so you can see that the grid for the entire building has actually been determined based on the parking layout. So you can tell that these sorts of traffic requirements, the requirements of space width, the number of parking spaces, and the arrangement and layout can have quite large implications for the design of the building, the entire building itself. Obviously, we're driving down here and around the core of the building here, which seems to be the elevators and stairwells and lifts, but then we've got to accommodate space for columns and so on to help hold the rest of the building up.